Here's a disturbing question. How do you know that everything you remember, your childhood, your name, watching this video, actually happened? What if your entire conscious experience was just a random accident of physics? Welcome to Großdenken, my friends. Today, we will explore the Boltzmann Brain Paradox. It's one of the strangest thought experiments in all of science. And it emerges directly from the laws of thermodynamics. Let's count down the 5 key things you need to know. Please support this channel grow by just subscribing. That would mean a great help. The Boltzmann brain is named after Ludwig Boltzmann, the 19th century physicist who pioneered statistical mechanics. Boltzmann realized that temperature and entropy, the measure of disorder, come from the random motion of atoms and molecules. In a gas at equilibrium, particles are constantly moving and colliding randomly. But here's the key insight. Random fluctuations can occasionally produce ordered arrangements. Given enough time, particles could randomly assemble into any configuration, including a functioning human brain, complete with memories. That is the seed of the paradox. A Boltzmann brain is exactly what it sounds like. A brain that forms by pure chance from random particles in empty space. This brain would have memories, thoughts, and perceptions, just like yours. It would believe it had a past, that it ate breakfast this morning, that it's watching a YouTube video. But none of those things actually happened. They're just random neural patterns that appeared by accident. The brain would exist for a brief moment, maybe a fraction of a second, before the particles randomly drift apart and it ceases to exist. The paradox arises from a conflict between probability and observation. So, here's the logic. If the universe continues forever, or exists in an eternally fluctuating state, then random fluctuations will produce countless Boltzmann brains over infinite time. In fact, the number of Boltzmann brains would vastly outnumber normal brains that develop through biological evolution. So, if you pick a random conscious brain in the universe, it's statistically far more likely to be a fleeting Boltzmann brain than a normal one. This leads to a disturbing conclusion. If you accept certain cosmological models, you should believe that you yourself are probably a Boltzmann brain. But that feels absurd. You clearly have consistent memories and a coherent external world. That's the paradox. Physicists take this paradox seriously, and many have argued against it. Richard Feynman, the legendary physicist, directly addressed this. He pointed out that if we were Boltzmann brains, we wouldn't expect to see order and low entropy in parts of the universe we haven't observed yet. But we do. Every time we look at a new galaxy or measure cosmic background radiation, we find more order, not random chaos. More recently, physicists Carlo Rovelli and David Wolpert have argued that the Boltzmann brain argument contains a logical flaw. It uses the laws of physics to conclude that our memories are unreliable, but we only know those laws because we trust our memories in the first place. That's circular reasoning. The consensus among physicists and philosophers is that you almost certainly are not a Boltzmann brain. There are several reasons. First, the probability of a Boltzmann brain forming is astronomically small, far smaller than the probability of a normal universe producing normal observers like us. Second, our observations consistently show a universe with a low entropy past and increasing entropy over time. That's exactly what you'd expect from a real universe, not a random fluctuation. Third, recent work suggests that when you properly account for what memory and observation actually mean, the Boltzmann brain scenario becomes self-defeating. You can't use reliable physical laws to prove that those same laws are unreliable. So here's where we land. The Boltzmann brain is a fascinating paradox, a stress test for our understanding of thermodynamics, cosmology, and probability. It reveals hidden assumptions in how we think about the universe. But it's not something you need to lose sleep over. The evidence strongly suggests you're real, your memories are genuine, and the universe around you actually exists. Still, the next time you're alone in a quiet room, you might wonder, are those thoughts really yours? Or just random particles briefly arranged dreaming they're you? If you enjoyed this video, don't forget to like and subscribe. Thanks for watching.